Yeah, piling has been on focus for many years, and what we are going to present you today is a brief overview about the final clause 6, pile foundations, and then we will focus on examples which are elaborated by Task Group B2, which will be presented by Patrick Insen, and in correlation to that, Loretta Bartali will show the results from the benchmark test. So I'm also not familiar with the results, so I'm looking also forward. I hope it's not it's a good surprise, let's say. And then we will continue, Bart Jansen will continue with presenting design examples which were elaborated by Task Group B1, more focusing on micropiles, pile rafts, whereas Patrick will focus on pile design by testing and ground investigation, and then we will have finally some discussion. So I will start with a brief introduction to clause 6, and I won't talk much about, let's say, history. So it's for each other clause a long process over the last 13 years. But what I would like to highlight is that this piling clause was, for whatever reason, on focus at the center of interest for many years. So we received comments, hundreds and thousands of comments for each draft we delivered. So that's just an example of the April 2019 draft. So I personally forgot about it, but as you might see, the blue one is just the clause 6, whereas, let's say, new clauses on ground improvement get much less comments. So that seems, for me, I interpret it in that way that piling is related to huge extent to national experience and practice, and probably that's the reason for this many comments we received, which it was also very difficult to compile them in a certain way. And we had also long-term discussions about what should be really the content of clause 6. So this is just, let's say, an evolution of the text volume, number of words counted, and you can see that we had phases where we doubled just the text volume and cut it back then in the following years. So actually we have more or less the same volume than we have in the first generation code. The basis for the evolution of clause 6 was, of course, chapter 7, the current chapter 7 pile foundations. So that was the basis, and if you compare it, you will see that it's also a reasonable evolution of the regulations, of the recommendations we have currently. So the structure of clause 6 is the same as for any other clause of part 3. Worth to mention is that we have a quite comprehensive annex providing, from my point of view, really helpful and supportive content. For example, on the classification of piles that's needed only for the partial safety factors. You will see that later on. But we have included also many and also new calculation models, empirical models, where you can evaluate the axial pile resistance based on ground parameters, CPT, pressure meter profiles, but also new empirical tables. And we have also included detailed information how to calculate, for example, down drag due to vertical ground movements. I will talk about that briefly later. And also about the evaluation of the resistance of pile groups to axial tension. Some approaches also to calculate single pile settlements and due to axial loads and also lateral displacements. So some regulations to address the SLS verifications. And that's also new, quite comprehensive guidelines for calculating buckling and second order effects. So that's also a new regulation and recommendation how to deal with that, and also some basic recommendations on dealing with cyclic loaded axial loaded piles. So I think all these are informative. They might be adjusted to national practice, but I think provide some really helpful guidance. As for all other structures, geotechnical structures, the pile design is influenced by the new structure. So we need, of course, EN 1990 for evaluating the actions and the partial factors on actions, and also considering the fundamental specification of the verification cases. And we need also EN 1990 Part 1 with regard to classification of pile foundations into geotechnical categories. In most cases it might be geotechnical category 2 and sometimes also category 3. And for the consequence factors we need for the pile design, and for the basics for ULS and SLS verification. Of course, we need a ground investigation in each case for pile foundations. So the basics are provided in Part 2 of Eurocode 7, but in Part 3 we define the requested exploration depth for pile foundations. So that's a little bit split up. And of course then, of central meaning is clause 6, where you find all the information about the requested ULS and SLS verifications, where you find a request on the calculation models for pile foundation, and also all the sets of factors like model factors, correlation factors, and partial factors, which I will present in an overview in the following minutes. I will just focus on some principles and some major modifications, and so just on the essentials. And to start with the evaluation of the axial resistance of single piles, it's based, as it was in the past, or it's currently, on calculation or testing, or in combination with national regulations on prescriptive rules. In case you are doing design by calculation, I think that's the common way, we have two options: either to use ground properties determined from, let's say, the sum of field and laboratory tests, and to evaluate the pile resistance, and this approach is called ground model method. Or second approach, you evaluate individual pile resistances determined from correlations with field test profiles. That's mainly soundings like code penetration tests, pressure meter tests, and so on. And this approach is then called model pile method, and Patrick will explain that application in more detail. So that can be used also in combination with the calculation models, which are documented in Annex C. In case that you are doing design by testing, you might either execute static pile load tests for ULS and SLS verification of piles in compression and tension, or in case that you are just focused on ULS verifications of piles in compression, of course also dynamic impact or rapid load tests. And you can see on the right side that in case of application of the ground model method, you are gaining the representative value of the pile resistance just by the calculated value, whereas for the model pile method and for the design by testing, we have to consider the scattering, and that means you have to apply correlation factors in the same manner as we do that currently. It's probably worth to mention that we formulated requests on the confirmation of pile design by calculations. That means you should apply site-specific load testing or comparable experience just to validate your prediction by calculation. And we have defined a minimum quantity of load testing, either as an ultimate pile load test or as a serviceability pile load test for the confirmation of design. And site-specific ultimate control tests may be omitted only if there is really extensive comparable experience available. When we evaluate the design value of the pile resistance, we have to consider additional aspects which are covered by three sets of factors, namely partial safety factors, correlation factors, and model factors. And it's worth to mention that the set of factors were modified in comparison to the current code, and we try to establish a more stringent concept. That means that we especially adjusted the previous correlation factors in a way that we have split it up to what is still called correlation factors, but which have the intention just to consider the spatial ground variability, whereas additional specified model factors should consider the uncertainty related either to the calculation model in case of design by calculation, or in case of design by testing, the uncertainties related to execution and evaluation of pilot tests. So we have established different sets of correlation and model factors for each case that you are doing design by testing. That means for static load tests, for rapid load tests, and dynamic impact tests, what offers you the possibility to specify different sets, for example, for rapid load test than for dynamic impact tests. So it's, let's say, it's quite easily able to be adjusted to national experience. Yeah, and already mentioned the partial safety factors. On the following slides, I will give you an overview about these sets, which all can be adapted to national experience as they are NDPs, whereas I personally hope that there is not too much adjustment in the different European countries, just to stay with the idea of harmonization. And you see here an overview about correlation factors which should be applied in combination with a model pile method designed by calculation. You see that it's still related to the number of tests or profiles in this case of soundings, but that there are also some modifications included. For example, also the coefficient of variation of the test results is considered, and there's also an approach now implemented which goes back to experience in France and Belgium, that you can consider a more intense ground investigation in order to reduce these correlation factors, what is from my point of view really reasonable. Yeah, model factors, as already mentioned, are related to the uncertainties included in calculation and testing, and you see here the numbers, the box values for application of ground model method. It's obvious that if you are executing a confirmation by ultimate pilot test on the side, that you can reduce the model factor, whereas if the information are limited, you have to apply larger model factors. And in the lower part of the table, you can see the factors which are proposed to be applied in combination with the model pile method, so slightly different values depending on the basis for this evaluation on the kind of soil investigation. Here, just as an overview table with the model factors for verification of axial pile resistance by testing. And of course, the numbers are, the smallest one are for static load tests, so it's basically 1.0, whereas we have different sets of model factors for different type of testing, rapid load tests, dynamic tests, and so on. So that is what I mentioned. This can also be adjusted if you intend to have different numbers. Currently, the numbers are quite similar for rapid load tests and dynamic impact tests. And it depends also on the type of soil. We are aware that we have in fine soils higher uncertainties if we are executing dynamic tests than in coarse material or in rock. Yeah, and just a brief overview about partial factors for the verification of ultimate resistance of single piles. So you see the numbers here are splitted up for, let's say, different type of piles, so that can be considered, and also different numbers are proposed for base and shaft resistance, so we have all the options to adjust these numbers to your personal experience. I show the table in full extent, and just to highlight that our mandate, which we originally had in evolution of the second generation, that means to harmonize verification concepts and to minimize national determined parameters, that we were quite successful from my point of view with regard to the design of piles. So that means for axial loaded piles, we just propose to use the resistance factor approach in combination with verification case 1. So that's a harmonization, I would say, based on the situation evaluated at that time by Andrew Bond, where already currently many countries are using design approach 2, also yellow marked ones, and the other ones agreed on this, let's say, harmonization, that we have the RFA approach for axial loaded piles, whereas we are used for laterally loaded piles, the material factor approach basically. Yeah, a further, from my point of view, quite important improvement is that not only single piles, no longer single piles are considered by Eurocodes 7 part 3, but also equivalently pile groups and pile rafts. I think that reflects engineering practice. You quite seldom have just a single standing pile. And you see here just an overview about the requirements on the design of pile groups and of pile rafts. So it's basically requested that you consider all the relevant interaction effects, pile-pile interaction, for example, for pile groups, and for pile raft, in addition also the pile raft interaction, as that influences the behavior of piles as part of this overall structure, and you then evaluate the overall resistance either of this pile group or the pile raft. There's no necessary to really prove or verify the resistance of single elements of these structures, and in this sense also the verification is just based on the overall resistance of the structure for both cases, the group and the pile raft. And we have a separate set of partial safety factors for the verification of such structures, whereas if you focus just on the vertical resistance, the numbers you find here for the model factor, for the partial safety factor, sorry, 1.4, it's comparable to spread foundations, to single piles, and there's a possibility to consider the quality of the calculation or simulation model you are using by specifying here the model factor, the box value, unless the national annex gives a different value, is 1.0. So the basic idea behind that is that we tried to establish in Eurocode 7 part 3 a smooth transition for all kind of foundation types. That means a stringent concept which results in a comparable overall global safety factor. That means if we consider all these different foundation possibilities, spread foundations, ground improvement, with rigid inclusions, for example, with and without load transfer platform, pile raft and pile foundation, the idea is that we result in a comparable safety level, global safety level, and I think that's quite reasonable as the interactions we have to consider, for example, for such a ground improvement without a load transfer platform, it's absolutely comparable, of course, to a pile raft. So from the soil mechanical point of view, that's totally reasonable. Yeah, further major modifications. We implemented much more detailed guidance for consideration of actions due to vertical and horizontal ground displacements. That's especially down drag, heave, transverse loading. And you see here as an example some regulations for considering the down drag effect. That means we have provided detailed rules for calculation of the down drag. It's basically based on a displacement-driven approach that we evaluate the level, the neutral point or level where the settlements of the piles and the settlement of the surrounding ground are equal, and above that level we have negative skin friction, beneath we have positive skin friction, and that's the approach, and that's provided concerning the calculation model in detail, and also the verification process is specified. That means you have, for example, in this example, to consider this downdrag as a permanent action. Further improvement is that we have established numerical calculations for pile foundation in addition to analytical or empirical methods. And for pile groups and pile graphs, that's the use of numerical methods is explicitly recommended as the most reliable approach, which is able to consider the interaction effects and the stiffness of the raft and the displacements and interaction effects. And of course, you find more guidance than in part 1 on the verification by numerical models. Yeah, to conclude, the pile design, according to the second generation of Eurocode 7, is an evolution of what we know already from the first generation rules. So it's not a revolution, but really an evolution. And we are covering now many additional design aspects, like I mentioned, pile groups, pile graphs, the application of numerical simulations, consideration, evaluation of impact by ground displacements. So I think that's quite supportive guidance for engineering practice. And I showed this evaluation, let's say, of the volume. At the end, we concluded that we intend to specify the basic requirements for analysis and verifications of pile foundations, but not really something like a comprehensive textbook. So there is room, and it's also reasonable that additional national guidelines, recommendations may be applied and may be used in combination with the new Eurocode 7. And as I mentioned, all sets of factors are nationally determined parameters, so they can be adjusted according to national experience. Not only the values, but also part of the tables might be modified, whereas, as I already mentioned, hope that we can stay with a harmonized approach throughout across Europe, and that the modifications are not too severe. So in reflection, from my point of view, Clause 6 reflects up-to-date European consensus for pile design. As I mentioned, we have considered hundreds and thousands of comments and tried to find acceptable compromises for each issue. And so I personally hope that this Clause 6 provides a modern framework for state-of-the-art pile design, and that it's compatible to national experience and approaches. So far, a brief introduction. Thank you for your attention, and I think pile design is always quite interesting, because we have to combine, let's say, project-specific investigations, testing, with general calculation and verification approaches, and these are just some impressions from a quite extensive testing program in Hamburg in Germany. Thank you very much.